Hello, this is Dr. Pavan Kumar Reddy, Assistant Professor, Department of Artificial Intelligence and Data Science, BVR 18, Narsapur campus. Today we'll discuss about the chapter course is Whoops through Java. Today topic is polymorphism, abstract class and its method. I'll refer this textbook Java Complete Reference 9th edition and other internet resources. Today we will discuss about the polymorphism. Before going to subject, what I mean by polymorphism? Here polymorphism is derived two words. First word is poly, second word is morphs. Here the word poly means many. Morphs means forms. So polymorphism is many forms. Here polymorphism are two types in the Java programming. First one is complete polymorphism, second one is the runtime polymorphism. Here the polymorphism can be performed in the Java by using method overloading and method overriding. First of all, what I mean by compile time polymorphism? Here the compile time polymorphism can be achieved through the method overloading. At the compile time, the Java knows which method to call by checking the method signatures. So it is called as a complete polymorphism or static or early binding. Here method overloading says you can have more than one function with same name in one class. With the same name in one class. He is with different prototype. That is the compile time polymorphism. See this example. Here class is a animal. Here the method is eat method, another method is eat method. Either say this one is implementation part, this one is the method. Here the another method name is eat method with one argument, that argument is string str. Here the main method is there, main method here. Here animal A equal to new animal. Here we are creating the one object for this class. Whenever call the eat method, it will goes to the here. It will goes to here. Whenever call the eat method with the one argument, it will goes to this method. The final output is dog is eating, cat is eating. This is the two outputs. Coming to the runtime polymorphism. Here runtime polymorphism can be achieved through the method overriding. Here the Java virtual machine determine the proper method to call at the runtime, not the compile time. So it is called as a dynamic polymorphism or late binding. Here method overloading says, what do you mean by method overload? The child class has the same method declared with the parent class. That means the child class can be provide the specific implementation of the method that has been provided by the one of its parent class, that is called as a method overriding. See one shortcut in the form of defining the compile time and runtime. Here coming to the compile time polymorphism. Compile time polymorphism is also known as static polymorphism or it is also known as early binding. Early binding. Whenever come to the runtime polymorphism, it is known as dynamic or late binding. Late binding. It is the best example of compile time polymorphism is method overloading. Method overloading. The best example of runtime polymorphism is method overriding. This is the runtime polymorphism and compile time polymorphism. One of the important thing is a superclass variable can be referred as a subclass object. A superclass variable can have the reference as the subclass object. See this example. Here method is a class A. In that method is there. That method is the call me method. In that call me method, the implementation is this one. Whenever create the another class, the class is a child class. B is a child class. It extends the A. In that child class, method is same. That method is call me method and implementation is there. Now we can create the another class. This child class C is a child class. That will be extends to the B. Here also using the one method. That method is call me method. Here also one implementation. Coming to the main class, public void main. Here we are creating the object. A is for A class. B object is a type. B object is creating for the B class. C object is creating for the C object. Now here we are taking as a one reference. That reference is called as A is a class name, R is a reference of the type. The reference of the type A. Here we are assigning the one variable. That variable is a R equal to A, reference equal to A variable. Whenever call the call me method, it will goes to the here. What the implementation is there inside a call me method. That statement will be print on the terminal. Whenever assigning the another object is taken as a reference, whenever call the call me method by using the reference, this will be goes to call me method. What is the statement here? Inside B call me method. This statement will be print on the terminal. Whenever we are taking as a C as a another reference object, R equal to C. Whenever call the call me method, it will be goes to here. What are the statement here? Inside C call me method. The three statements are printed on display on the terminal. This is the compile time and runtime polymorphism. See one more example. Here the class is figure class. Here we are assigning the two instance variables and the method is figure method. We are pass the two argument. That argument is double A and double B. Here this A will be assigned to the dimension 1, B is assigned to the dimension 2. Here the one method is there. The method is the area method. This is the implementation. That is the return type is 0. Here we are creating the another class. The class is a rectangle class. This class will be extends to the figure. Figure is this class. Here also in this rectangle class two arguments are there, W A and B. Here we are assigning the super keyword. Here super keyword. Now here this double area is override method with the rectangle. Already area is used in runtime polymorphism and this area is already used in rectangle class. Here methods are same, so these methods are override with classes. Now one more class is triangle. The triangle class will be extended to the figure class. Here also same, the method is there, assigning the super keyword for the a and b parameters, and also this one is also a override. Here there is a three methods. First method is area method for the which class? Figure class. Figure class area method is there. Another class is rectangle class. Rectangle class. This one is the area is there. Another class is triangle. The method is area method. Methods are same with override with this class. See here, coming to the type is different. In the first figure class, the return type is 0. The next class, the type is dimension into dimension 2. The next class, the return type is 3. So here method is different. Method name is same with return type is different, class name is different. That is called as a method overriding. See this example. In that class, find area, we can find out the area, the main method. Here figure is a class, we are creating the object creation. This is for object creation for figure, and also can pass the two parameters. Now here one more class is there, the class is the rectangle class. We are creating the R class, new rectangle. This is for R class, this is for triangle class. Triangle class, we are creating the one object, that object is called as a T. Now we are taking as a reference variable. Figure is a class name, fig ref is a reference. This reference we are assigning the R value, R. That is the what is the statement? Area is figure ref dot area. Whenever call the area figure reference dot area, figure reference is figure class, this figure class. In that figure class can find out the area. What is the, can also here pass the two parameter, 10 into 10. This return type is 0, undefined. The statement will be print on the, this statement will be print on the here inside area of rectangle. Now triangle, coming to the triangle class, figure reference equal to triangle T. The statement is figure reference dot area. Whenever call this figure reference area, whenever call the figure reference area, it will be directly goes to here, directly goes to here. This statement is, this output will be displayed. Whenever creating the another class, figure class is this one. The figure class is figure reference dot area. Whenever call the figure reference dot area, it will be directly goes to here, the return type is 0. First one is the triangle, second one is the, first one is the rectangle, second one is the triangle, third one is the figure. These three statements will be displayed on the terminal. This is for the another example for method overriding. Coming to the one topic, the topic is instance operator. Instance of operator. What I mean by instance operator? Why we are using the instance operator in the Java programming? Here the instance operator is used to test whether the object is an instance of the specified type. When the object is an instance of the specified type. The type is either class type, either subclass, or either interface. Here the instance of operator in Java is called as type comparison operator. It is because can compare the instance with the type. Instance with the type. The return values are either true or false. It will be applied the instance operator with the any variable, it is treated as null value. It can be returns false. What is the syntax of instance operator? Here the instance operator syntax is object name, instance of class name. This is one example. Here the class name is simple class, main method is there. Here we are creating the one object, that object is S for the simple one class. Okay. Here in that system.out.println statement, S is instance of simple, S is a object, instance of, we are using the instance operator whether the object is present in the class or not. When the object is present in the class, it will comes to the true. When the object is not present in the class, the output is false. That is the instance operator. Here, what is the difference between method overloading and method overriding? Here, see the first one. Method overloading is used to increase the readability. Whenever coming to the method overriding, it is used to provide the specific implementation of the method. This method is already provided by the superclass. Second one, the method overloading is performed within the class only. Method overriding can be occurs two or more classes. That is called is a relationship. Is a relationship means it is called as a parent child class. That is the inheritance relationship. Here the third one is method overloading parameter must be different. In case of method overriding, parameter must be same. We are using the same parameters. Here method overloading is the best example of compile time polymorphism. Method overriding the best example of runtime polymorphism. Here the last two difference is, in the Java, method overloading cannot be performed by the changing the return type of the method only. The return type is the same or different in the method overloading. Here the return type must be the same or covariant in the method overriding. This is the difference between method overloading and method overriding. See this one example. Here the bank is a parent class. SBI is a child class. This is also a child class. This is also a child class. Okay. Whenever here the SBI child class extends to the bank. The ICICI is extends to the bank. The Axis is extends to the bank. Here bank is different, classes is different. Here the bank class, in the bank class the method name is get rate of interest. The method is same for all classes. Okay. Here type is integer type, the implementation is different. That means method overriding means classes is different, method is same, but this method implementation is different. That is called as a method overriding. How to write this Java program based on this diagram? First, what is the class? Bank. What is the class? Class is bank. Bank is a class. class is bank. In that bank method is get rate of interest, get rate of interest. Here this child class will be extended to the parent class, that is class SBI extends bank. Here the method is, what the method, get rate of interest method, and also implementation is different. Now this class will be extend to ICICI extends to bank. Here all the method is the same method, get rate of interest method is the same, the implementation is different. And one more class is, the class will be extends to Axis extends this class, bank class. Here all the get rate of interest is and implementation is different. Here to write this example. See this one. Here class name is the previous set, based on the previous diagram, the class parent class is a bank, and the bank child classes will be extends to the bank class. This is the child classes. These three are the child classes. Here the common property is, common method is there. The method is get rate of interest method. This is the implementation. Here the class SBI extends to bank. SBI extends to blank. Method is there. Return 5. Return type. This is implementation part. Okay. This is the parent class. This is the child class. Here one more child class is there. The child class is ICS is a child class extends to bank. Here the method is same. But implementation is different. Previously return 0, return 5, now the return is 6. The rate of interest is 6. Okay. Here one more class is there, the child class, that is Axis child class. It will be extends to the blank class. Method is this. Implementation is different. Now we are creating the one main class. The main class is display result. We are creating the main method. Here S is a object. This object is creating the one class. That class is SBI class. I is creating for the ICSI class. A is creating the Axis class. Here the three objects are created. These are the objects. Now system.out.println, the rate of interest in SBI is, whenever call the get rate of interest method, yes, this method will be called this based on the S object. What the S is? SBI. Whenever call this method, it will be goes to SBI class. What is the method is? Get rate of interest method. The implementation is return 5. That means percentage 5 will be displayed. The next one, ICICI Bank. Whenever call the get rate of interest method by using the I object, this will be goes to the ICICI class. What that value is? Here 6 value is there. That 6 percentage will be displayed on the terminal. Whenever the call the get rate of interest is for Axis Bank, it will be goes to here. It will call the goes to Axis class. what you can call the get rate of interest method, and the return type is 7. The 7 value will be printed. That is called as a method overriding. Here remember this. Here we are creating the 3 objects. We are creating the 3 objects for 3 classes. 3 objects, 3 classes. Remember this one. We will discuss with the next two slides. Here coming to the abstraction. Here there is a situation in which we define a superclass that declare the structure of the given abstraction. Without providing complete implementation of the method. Here the abstraction is a process of hiding the implementation details. And showing only functionality of the user. Here one example is void add. We can add the 2 numbers only. Okay, in that programming it will be in that abstraction. Void add is a only structure part. You see this one. Void add is a structure part. Thus implementation is somewhere in the classes. Implementation will be assigned this somewhere in the classes. This is the void add, that is the structure part. This method add method, this is implementation part. Simply in the programming, implementation part is only declared with the open braces and close braces. Here a class, what do you mean by abstract class? A class which is declare a abstract is known as abstract class. It can have the abstract and non-abstract method. Here simply abstract class consists of 2 things. First one is abstract, second one is non-abstract. Here what I mean by abstract means there is no implementation. It will be only declared with the structure. What about the non-abstract? Non-abstract will be display the implementation. This is the difference between the abstract and non-abstract. Simply abstract is the no implementation, but non-abstract is a implementation. You note this. One more important thing. The abstraction lets you focus on what the object does. You know what the object does instead of how it does it. What that meaning? We know what we can only focus on the object does, how it does not, how does it. That is the thing of abstraction. Here there is a 2 ways to achieve the abstraction. First one is abstract class, second one is the interfaces. Coming to the abstract class. Here what is the definition of abstract class? A class which is declared as abstract is known as abstract class. It is also having the abstract and non-abstract. Here the non-abstract is called as a concrete method. It needs to be extended and it is implemented. It needs to be extended and implemented. It cannot be instantiated. What is the meaning of instantiated? Mean in the abstract class, object is not created. What is the syntax of abstract class? Here the abstract class, the class is created by using the abstract keyword with class name. class name. Here what I mean by instantiated, see this one. Here we are creating the one class, that class is a class A and A object. Here the object is only declaring for the particular class. The object is only declaring the particular class. That means we are creating the reference. The object is not created in the abstract class. The object is not created, just declare in the abstract class. That is the meaning of instantiated. Here what I mean by abstract method. Here the abstract method which is declared as a abstract, and does not have the implementation, that is called as a abstract method. See this example. Abstract method is followed with the abstract keyword, the method name. Here there is no body and the abstract. What is the rules of the Java abstract classes? First rule is, these are the 5 rules. First rule, see this first one. An abstract class must have the with an abstract keyword. The abstract class followed with the abstract class with the class name. Okay. Second one, it can have the abstract and non-abstract method. Already what is the abstract and what is the non-abstract method? Means abstract method is only structure, no implementation. There is no implementation in the abstract class. What about non-abstract method? The non-abstract method is structure plus implementation. Abstract method and structure and implementation, that is called as a non-abstract method. Here the third rule is, it cannot be instantiated. Means object is not created. Object is not created. Here the fourth one is can have the final methods. The fifth one is can have the constructors and static methods are also used. These are the rules under the abstract class. See this one example. Here the class is class A. The class will be follow the abstract keyword. Here the call me is a abstract method. Here the non-abstract method is only implementation part. Here the implementation part is also use the call me method. This is concrete method. You have to display the statement in the terminal. Here class B is extends to class A. You are creating the one class. The class is class B. In that class also used to call me method. Same method name. In the whatever the abstract class method is there, same method will be used. Here this one is the implementation part. This one is the second implementation. Now we are creating the one class. Use the main method. Here see, observe this one. We are creating the object. We are creating the, here what are the main in the abstract class? The object is not created. The object is reference of the B. New B. Object is reference of the B. Whenever call the call me method, it will be goes to where the call me method. Here it will be goes to here, call me method. Whenever call the call me to method by using the B object, it is goes to call me to, not this one. Whenever call the call me method, it will goes to here. The two statements will be displayed on the, this is this one. These two statements are displayed in the terminal. Coming to the, sir, what is the difference in normal class and abstract classes? In that normal classes, we are creating the three objects. We are creating the object for particular classes, each class. Here we are creating the only one object for different classes. Classes is different, object is same. Just we are taking as this object, B object is a taking as a reference, not created, just we are declaring the object to the class. Here there is a three important things in the abstraction. Here see this one. The abstract class can have the data member, abstract method, method body, constructor, and even also main method. If there is any abstract method in the class must be abstract. The abstract method will in the class, whatever the method will be assigned, whatever the method will be there in the abstract class, that method is called as a abstract method. Abstract method. If you are extending the any abstract class, if you are extending the any abstract class that have abstract method, or you must either provide the implementation of the method, you must provide any implementation of the method, or make this as a abstract. Here see this one. In this example, what is the third one? Whenever extending the any class, the class B is extends to A class. Here we are providing the abstract method. Abstract method. If the abstract method is not there, this class is taken as a abstract class. Abstract class. That is the third thing. Third one is, if you are extending any abstract class, the class abstract method, comma, you must either provide the implementation of the method. This is a implementation of this. This one is implementation method. This method is already available in the abstract class. Otherwise, this class is treated as a abstract class. Here, see this example. There is a three examples are there. First example, see, first scenario. Here, the shape is a abstract class. The shape is a abstract class, and its implementation, this implementation is provided by the rectangle and circle classes. Mostly we don't know about the implementation class. That means can hiding the end user, and the object of the implementation class is provided by the factory method. That method name is called as a draw method. Okay. Here shape is one abstract class. Shape is a abstract class. In that abstract class, what is the abstract method? That method is draw. Void draw method. Now, implementation is provided by the rectangle and circle classes. Here we are creating the one class. That class is rectangle class. The class will be extends to the shape class. Here class rectangle extends shape class. The implementation is also followed the abstract method where implementation. Now we are creating the another class. The class is circle class. Here class circle extends to shape. Here also we are also abstract method. That method is void draw method. The implementation part is here. This is entire this one. This is one implementation. This is another implementation. See this example. Here what is the class name? Abstract class is shape class. In the shape class, the method is draw method. This draw method is a factory method. Here in this scenario, the implementation is provided by the another class. Here the another class is rectangle class. This class will be extends to the class. Here also using draw method. This is the implementation. One implementation for draw method. It implementation by the other class. The class is a circle class. It will be extends to the shape class. It is also a another implementation. That will be followed by the abstract method. Now we are creating the one class. The class is a test abstract one. Here method is there, main method. We are creating the one object. This object is for referencing the class equal to new circle. Here based on this class, we are creating the circle method. Whenever call the draw method, whatever the message will in the draw method, that message will be displayed on the terminal. For suppose here shape s equal to, this is for the circle class. Now we can draw the rectangle. Here s dot draw. What the output? Whenever creating the rectangle method, it will goes to here drawing here this one drawing rectangle. Simple thing here, taking as object is declaring as a reference of this particular class, not creating any object in that abstract classes and methods. Whenever call the draw method, will be directly goes to whatever the message in the draw method, that message will be displayed on the terminal. This is the drawing circle. See this another scenario. Here bank is a abstract class. And its implementation is provided. Means we are extending to the one class another class, and the method is rate of interest method. Now we are writing this program. The class name is bank class. Method is the get rate of interest method. The implementation is return 0. That is the abstract method. Now the implementation is provided by the another classes. So we are creating the another class. Method implementation, and the implementation provided by another class, that class is SBI. It will be extends to bank. What the method name is get rate of interest method, and the implementation is 6. Now the abstract method is declared. Now we are creating the one class. That class is test2 class. Here main method, B is declaring the B object declare the class, that class is B object is declared the class is bank class. So discuss only bank class. B is declared. B equal to new ICICI method. B is ICICI method. We are creating the method, that method is ICICI class. Based on this ICICI class, whatever the implementation statement, the statement will be displayed. Here system.out.println the rate of interest of ICICI, B dot get rate of interest, B dot rate of interest. Whenever call this method by using the B is a reference of that bank class. Here what is the output? What the output will be goes to here. What is the implementation? The rate of interest is 5. Now B equal to new SBI. B equal to new SBI. Here the rate of interest of SBI is B. Whenever call the get rate of interest method by using B object, here it will goes to here. The two statements will be print on the terminal. This is the another scenario. See the one more example. Write a program in Java to create an abstract class. Is the class name is shape that contains the empty method. The method name is number of sites, and it provides the three classes. First one trapezoid, second one is triangle, third one is hexagon. Such each of one the classes extend the class is shape. Each one of the class contain the method. The method is number of sites. That shows the number of sites in the given geometrical figure. Uses the site to find the perimeter of the geometric figure. See this scenario. What is the class name? Abstract. We are writing the class. The class name is abstract class. The class name is shape. In that, what is the method name in the abstract method? Number of sites. I am writing the roughly number of sites, that is the method. The statement is what that return, whatever the statement is there, implementation. Okay, yeah, that one is the statement is over. When provide the three classes, the first class is class trapezoid extends shape class. This is the class name. This class will be extended to this one. This class is also using the reference of the abstract method. The abstract method is number of sites. Already in that example there is declared the method name is number of sites. The statement, whatever the statement will there, the statement is there. The another class is triangle class. Here class triangle extends shape class. Shape class. Here also using the same method. That method is number of site. The implementation part is there. One more class is there. The class is hexagon class. Now we are writing the another class. The class is class hexagon class. This class is also extends to shape class. This class is also used with the abstract method. That abstract method is the number of sites. We are using this method. on whatever the implementation is there. That so here class name is same shape class, provided the implementation trapezoid class, triangle class, hexagon class. Method is number of sites method is there. 3 classes. That statement is in the given example. Write this program. Here abstract class abstract class shape is a class. This shape class consists one method. That method is abstract method. That the method name is number of sites method. Here the implementation is provided by the other classes. The implementation is provided by the another class that already given the question. Here the what are the three classes? Trapezoid is one class, triangle is another class, hexagon is another class. These 3 classes are extends to shape class. Okay. Here each class is also using the same method. Each class also use the same method. In that method the implementation is different. Okay. Here shape is one class. This class consists of one method. That method name is called as a number of sites. Here the class implementation is provided by the other class. That class name is called as a these 3 classes. Each class consists of same abstract method. Each method the implementation is different. Write this main class. You are writing the main method. Here we are declaring the one reference. That reference is called as a shape S equal to new trapezoid. Whenever we are writing the trapezoid method, it will be goes to trapezoid class. This will be goes to directly here. This one is directly goes to here. Okay. Whenever call the number of methods, this one. Now we are writing the another class. The class is triangle class. Whenever in the triangle class, what the method name? Number of sites method. Whenever call the number of sites method, will be goes to here. Here another class is hexagon class. When in that hexagon class, what is the method? Abstract number of sites method. Whenever call the number of sites method, will be goes to here. So what is the final output? The number of sites trapezoid is 4. The number of sides of triangle is 3. The number of sides in the hexagon is 6. That will be 6. This is the 3 output.
Like, share and subscribe. Hit the bell icon for more updates.